Hi folks, welcome back to Physics with Captain Rod. The purpose of this video here is to show how to find the speed of an object that's undergoing circular motion and find its centripetal acceleration. So what we're looking at, imagine this, I don't know, round like record player type of geometry that's free to rotate about the center here. Let's imagine this example is rotating at 20 revolution per minute, and I'm just making up some sort of number. And imagine we've got some object sitting on this. So as this circle is going round and round and round, this object, if I were to draw kind of a motion diagram for it, its motion might look something like this. And again, if you if you have to go back and you look at my video about motion diagrams, where the dot basically is just representing this object. So as a time delta t goes by, the object might be here, and then here, and then here, and then here, and so forth. An important thing to realize in this problem is that as long as this rotation rate is not changing, and as long as this distance is not changing, this object's going to move at constant speed. And that's why these distances, like this distance, this distance, this distance, would basically be the same and equal. Now, to calculate the object's speed, I'm just going to use this basic formula here. Right? Speed is distance over time. You notice I talked in terms of speed instead of velocity. I find that when you're dealing with circular motion, it's just kind of easier and less complicated to talk in terms of speed because for most problems, because the velocity is in fact constantly changing. This object's velocity is changing in direction. Right, and that's why we would say this object is accelerating. So anyway, getting back to calculating speed, speed is distance over time. And in this example, this object's speed is not changing. So what that means is we can choose any time we want. Based on how the angular velocity is given, this 20 revolution per minute, I'm going to go ahead and choose to use a time frame, a delta t, of 1 minute. Which is 60 seconds. And the reason for that is I will know then that this object went around 20 times. So when I calculate the speed, all right, distance over time, this object went around 20 times, and each time it goes around, it travels one circumference of a circle, 2 pi r. So 2 pi times, I'm going to go ahead and write this in standard metric units. 50 centimeters is 0.5 meters, so 2 pi r would be 2 pi times 0.5 meters. And then the delta t, 60 seconds. I got to get back up to the top here. The 2 pi r represents the distance traveled once around. But if I use a 60-second time frame, this object will have went around 20 times. So I'm going to go ahead and multiply that by 20. And now all I got to do is calculate a value here. So give me a moment. And what I got out of this is about 1.05 meter per second. Top works out in meters, bottom seconds, 1.05 meter per second. I'm going to run that one more time to be sure. Yep, okay, looks good. All right, so this object will be moving around in a circle. It'd be moving at a speed of approximately 1.05 meter per second. Next, we're going to calculate its centripetal acceleration. So again, because the velocity vector is changing in direction, we've got an acceleration. That acceleration, I'm going to draw that vector in red. Centripetal accelerations always point towards the center of curvature. And they have a magnitude equal to v squared over r. So in this example, the centripetal acceleration is going to have a magnitude of 1.5 meter per second squared over 0.5 meters. If you give me a moment, I'll calculate a value. I get about 2.19. I'm just going to round that to approximately 2.2 meter per second per second. Now, why would this be important? Well, if we drew any sort of free body of this object and we apply Newton's second law in this direction, the ma term would be mass times the 2.2 meter per second squared. And that's going to give you a value for the net force on this object inward, which is sometimes called a centripetal force. Now that centripetal force on this object could be coming from several different things. One, perhaps this object is just sitting on the surface. So this centripetal force might be a frictional force. maybe it's bolted down or glued down or something like that, or maybe there's some sort of ridge here trying to keep it from sliding off the surface. There's not enough detail in this particular problem to know that, but I just wanted to chat a little bit about why would we want to know this, the centripetal acceleration, because it will be important for any sort of free body or Newton's second law analysis of that particle. So the point of this video was how to calculate the speed of an object, basically that's going in a circle, and how to find its centripetal acceleration. I hope that this has demonstrated that well. Have a great day.